Hello, everyone. Welcome to our Deep Dive podcast, where today we'll be reviewing the paper InternVL 3.5 Advancing Open Source Multimodal Models in Versatility, Reasoning, and Efficiency. Are you ready to explore the latest in open source multimodal AI?
Absolutely. This paper introduces InternVL 3.5, a new family of open-source multimodal large language models, or MLLMs, that claim significant advances in versatility, reasoning, and efficiency. I'm excited to break down the innovations and results with you.
Great. Let's start with the big picture. What is the main motivation behind InternVL 3.5, and how does it fit into the current landscape of multimodal models?
The motivation is clear. While commercial models like GPT-5 and Gemini 2.5 Pro have set high benchmarks in multimodal understanding, open-source models have lagged behind, especially in complex reasoning and efficiency. InternVL 3.5 aims to close this gap by introducing new training strategies and architectural innovations.
That's right. The authors highlight that recent open-source efforts have focused on advanced reinforcement learning methods to improve multimodal intelligence. However, stable and scalable RL frameworks for MLLMs remain an open challenge. InternVL 3.5 addresses this with its Cascade Reinforcement Learning framework.
Exactly. Cascade RL is a two-stage process. First, an offline RL stage for stable convergence, and then an online RL stage for refined alignment. This coarse-to-fine approach is designed to improve reasoning capabilities efficiently and scalably.
Before we get into the details of Cascade RL, let's talk about the model architecture. InternVL 3.5 follows the VIT-MLP LLM paradigm. Can you explain what that means?
Sure, the model consists of a vision transformer VIT as the vision encoder, a multi-layer perceptron MLP as a connector, and a large language model LLM for text processing. The vision encoder processes images into visual tokens, which are then compressed and passed to the LLM for multimodal reasoning.
And there's also a new variant called InternVL 3.5 Flash, which integrates the Visual Resolution Router, or VIR. What does VIR do?
VIR dynamically selects the optimal resolution for visual tokens, allowing the model to reduce inference costs without sacrificing performance. It uses a patch-aware compression mechanism, so semantically rich patches are kept at higher resolution while less important ones are compressed more.
That's a clever way to balance efficiency and accuracy. Now, let's discuss the training pipeline. The authors describe three main stages: pre-training, supervised fine-tuning, and post-training with Cascade RL and visual consistency learning. Can you walk us through these stages?
Of course, in pre-training, the model is trained on a large corpus of both text-only and multimodal data using next token prediction loss. The data is diverse, covering image captioning, question answering, mathematics, OCR, and more. The maximum sequence length is set to 32K tokens to support long context reasoning.
Then comes supervised fine-tuning, or SFT, which uses higher quality conversation data and multimodal reasoning data in a thinking mode. This stage aims to instill long thinking capabilities and expand the model's skills, including GUI interaction and SVG understanding.
After SFT, Cascade RL takes over. The offline RL stage uses mixed preference optimization, or MPO, to fine-tune the model with preference, quality, and generation losses. This stage serves as a warm-up, ensuring high-quality rollouts for the next stage.
The online RL stage then uses Group Sequence Policy Optimization, or GSPO, to further refine the model's output distribution. The combination of offline and online RL in Cascade RL leads to better stability, efficiency, and a higher performance ceiling.
And finally, visual consistency learning, or VICO, is used to integrate VIR into the model, creating InternVL 3.5 Charity Flash. VICO minimizes the divergence between responses conditioned on different visual compression rates, ensuring consistent performance.
That's a comprehensive training pipeline. Now, let's talk about deployment. The authors introduce Decoupled Vision-Language Deployment, or DVD. What's the idea behind DVD?
DVD separates the vision encoder and language model onto different GPUs or servers. This allows the vision and language computations to run in parallel, reducing resource conflicts and improving inference speed. It's especially beneficial for high-resolution or multi-image tasks.
The results are impressive. DVD alone can accelerate inference by up to 2x, and when combined with VIR, the speedup reaches over 4x compared to the previous InternVL3.
That's a significant improvement, especially for real-world applications where efficiency is crucial. Now let's move on to the experimental results. How does InternVL3.5 perform compared to other open-source and commercial models?
The paper presents extensive benchmarks across general multimodal tasks, reasoning, text, and agentic tasks. InternVL 3.5 consistently outperforms other open-source models and even narrows the gap with commercial leaders like GPT-5.
For example, on the MMMU benchmark for multidisciplinary reasoning, InternVL 3.5 Charity 241b-Maseda achieves a score of 77.7, which is very close to GPT-5's 81.8. On MathVista, it scores 82.7, again approaching the top commercial models.
In text-related tasks, InternVL 3.5 also shines, thanks to its native pre-training strategy that includes a large amount of text-only data. This helps the model maintain strong language capabilities and avoid catastrophic forgetting.
The model's versatility is further demonstrated in agentic benchmarks, GUI tasks, embodied tasks, and SVG understanding. For instance, on SGP Bench for SVG understanding, InternVL 3.5-Maseda 241b-Maseda, Maseda, Shizenda Maseda, Maseda, which is nadir up directive or namifer.
Let's not forget about multilingual capabilities. InternVL 3.5 performs strongly across 6 languages on benchmarks like MMMB and MTVQA, outperforming many competitors, especially at larger scales.
That's right. The improvements are consistent across model sizes, from lightweight 1B models to the massive 241b-Maseda, 241b-Maseda.
All 1210 balance.
Now, let's discuss the ablation studies. The authors compare different training stages, SFT, MPO, and Cascade RL. What do the results show?
The results are clear. Each stage brings significant improvements. Cascade RL in particular provides orthogonal gains over MPO, with up to 12.2% improvement in reasoning tasks for the 2B model and 6.5% for the 241B model.
The efficiency gains from DVD and VIR are also validated. DVD alone accelerates inference by up to 2x, and VIR adds further speedup, especially for high-resolution inputs.
Importantly, these efficiency gains come with negligible performance loss. InternVL 3.5 Charity Flash maintains almost 100% of the original model's accuracy on high-resolution tasks.
That's a testament to the careful design of the VIR and VICO training stages. Now, let's talk about some of the specific benchmarks. How does InternVL 3.5 perform on OCR, chart, and document understanding?
On 9 benchmarks, including AI2D, ChartQA, TextVQA, and DocVQA, InternVL 3.5 achieves top-tier results. For example, the 4B model scores 80.0 overall, and the 38B model reaches 84.6, outperforming many open-source and even some closed-source models.
In multi-image understanding, InternVL 3.5 again leads the pack. The 38B model achieves an overall score of 67.4, higher than its predecessor and other competitors.
Real-world comprehension is another area where InternVL 3.5 excels. On benchmarks like Real-World QA and Wild Vision, the model demonstrates robust performance, especially as the model size increases.
The model's performance on comprehensive multimodal understanding and hallucination benchmarks is also noteworthy. InternVL 3.5 outperforms existing methods on MM-STAR and MM-VET and shows consistent improvements in handling multimodal hallucination.
Visual grounding is another strong suit. On RISI-COCO, RISI-COCO Plus, and RISI-COCO G, InternVL 3.5 achieves near-saturation performance with the 241B Jasmasada, Jasmasada, Jasmasalada, Jasmasada, Jasmasada, Jasmasalada, Jasmasalada, Jasmasada, Ladash, Skedida, Shokioda, Dansha.
The language capabilities of InternVL 3.5 are evaluated on a wide range of benchmarks, including MMLU, C, MMLU, C eval, GeoCAUEV, and more. The model consistently outperforms its base language models, thanks to the high-quality text corpora and Cascade RL.
The ablation studies further confirm the effectiveness of each innovation. Cascade RL provides the best trade-off between performance and computational cost, outperforming both MPO and GSPO in efficiency and effectiveness.
The efficiency gains from DVD and VIR are especially important for real-world deployment. As input resolution increases, the speedup from DVD becomes even more significant, making InternVL 3.5 suitable for high-resolution, multi-image, and video tasks.
The authors conclude that InternVL 3.5 achieves a 16% improvement in overall reasoning performance and a 4.05x speedup in inference efficiency compared to InternVL 3. The largest model, 241B Jasmasada, Jasmasada, Jasmasalada, Jasmasada, Jasmasada, should have focused.
GU.
The language capabilities of InternVL 3.5 are evaluated on a wide range of benchmarks, including MMLU, C, MMLU, C eval, GeoCAUEV, and more. The model consistently outperforms its base language models, thanks to the high-quality text corpora and Cascade RL.
The ablation studies further confirm the effectiveness of each innovation. Cascade RL provides the best trade-off between performance and computational cost, outperforming both MPO and GSPO in efficiency and effectiveness.
The efficiency gains from DVD and VIR are especially important for real-world deployment. As input resolution increases, the speedup from DVD becomes even more significant, making InternVL 3.5 suitable for high-resolution, multi-image, and video tasks.
The authors conclude that InternVL 3.5 achieves a 16% improvement in overall reasoning performance and a 4.05x speedup in inference efficiency compared to InternVL 3. The largest model, 241B Jasmasada, Jasmasalida, Jasmasalida, Shukid.
GU.
To summarize, InternVL 3.5 introduces Cascade RL, VIR, and DVD to achieve state-of-the-art performance and efficiency in open-source multimodal models, significantly narrowing the gap with commercial leaders and advancing the field of multimodal AI.